So, input output format is how your data set or your inputted data is going to be read and how it is going to be stored back into your HDFS. Whatever the type of a data, how it looks like, it will be read by the Hadoop framework itself. Basically, there are different type of input formats which are explained input format classes which are present in Hadoop. Okay, in the framework. So as I told, the data which we have stored, if it is stored in the form of a text input format, that is a text file, or if it is an XML file, you will have an XML input format also. And if it is of a database type, or when it is of a sequence file type, sequence files as a text or sequence files where you put filter. Accordingly, the input format will divide your data as a key value pairs. Not divide, segregate into key value pairs. Okay, this you remember, no? Like there were 5 lines of text. So the text input format, actually normally this is a commonly used one, commonly used input format, okay, by the framework. What it does, it divided this text input format into blocks of data or chunks of data, whereas it will add a key as a offset and value as the line itself. Okay, end of the line, then the line starting point as an offset, this line starting point, the next one is the offset, and end of the line as the key as the value. Okay, this is how it will divide the data. So this is the key value pair, which, as I told, it is going to be the input to our mapper function. Okay, and for further processing. Okay, so this is done by the input text input format, or based on the or based on your file inputs. So the primary class or this super class or the parent class for the input format is the input formats, okay, from which the file input format is derived. Okay, this is child classes, so we will be all usually concentrating on this text input formats. I mean, these are the types of input formats. One is the combined file input format, another one is the text input format. The text input format is the one which we have seen. Then key value input format. If your input file is in the form of key values, then we will use the key value input format. Okay, an end line input format is it is also possible in your while splitting of the data. Okay, this is like input splits, right? It is also possible while splitting of your data, you can specify how you wanted the splits to be. If you are using n-line input format, then you can specify, like say for example line 1 and line together you want it in a one input split. Okay, so what I mean to say is that the text data which goes for an input splits. Okay, input splits is happening for the text data in the form of offset and line itself, that is key value pair. In the input split itself, if you specify, like it you wanted the text to be divided, say n line input format. N line input format means, say you want 2 lines to be in a one input split, or 3 lines to be in a one input split likewise, then it is possible to specify that in your code. This input line format, normally we don't specify here, but there are settings. Okay, like get split, there is a method like a get split that you can get it how the split is happening, or set split. Okay, using that you can set the split. Okay, how many splits you wanted, or how you wanted the splits to be. Okay, so if you set that, then the input will be divided 2 lines into a one input split and 3 lines into your another input split. Hope you remember that diagram, right? How it is actually happening. Maybe I will show that too. So this is the diagram, right? The input format would go for input splits. This is the part of which we are concentrating on, input splits. So this how it is happening based on the input format. When it is n line input format, if you are dividing the text by one line, okay, each line with an key as an offset and value as the line itself, then if you specify n equal to 2, okay, then it will take the 2 lines as one input split. Now what it will do, this will be one input split, one input split, it means it will be like a 0 comma the line, and another split will be the 37 comma the line, and the another split will be some 40 comma the line. Okay, instead of that, if you say that you want this line and this line to be of a single input split, then from 0 to 37 36, right, it will be in a one input split. So that is also possible in your code, you can do that. Okay, this part only we are seeing how the data is splitted and what are the processing it is going. Okay, see, as I told, however you are taking the data and splitting it, likewise there are also output formats. Okay, output formats will be mostly of text formats, or if it is an XML file it will be of XML files, or if it is a database file or sequence of file, then it will be of that type. Okay, that will be stored in your HDFS again. So going back to that slide. Okay, so here they specify different types, I told, right? So key value pairs, if your data set is of a type of key value pairs, it is also possible, guys, because there is also databases, okay, where we store data in the format of map means key value pairs, right? If the data sets, if you are having a set of data like key value pairs, as example we can say that or we can say some examples are like uh, key value pairs. Any example can you think of? Like this many movies in the year 1991, if your data set is stored like this, 10 movies are what are the movies displayed, what are the movies released, or in the year 2021 what are the movies released. Okay, so the your data set itself will be coming as a data set likewise, not like the line or like a every time as a CSV file. Rather than that, it can be like this format also. Okay, in that case, how we are going to divide it into input splits, that will be taken care by this class. Okay, and sequence of file is a sequence of files, like you can think of a video files and image files. All those things are a sequence files, they will not have a particular end, right? Or a delimiter. Okay, for the CSV file we have a delimiter like a comma or separator. Any separator you can use it, so that you can tokenize the data and find the splits. But for the sequence file you may not have any delimiter. Then how to identify the delimiter and how key value pairs is divided, all this is taken care by the sequence file input format. Okay, if the sequence file is of a binary format, then you can use this class, or if it is a text input format, then this class will be used, or if the sequence file of input filter, if it is providing with a filter value, then you can use this class. And these are composite input format is like it will be combination of two or three input formats, like if it will have a text data also. If you remember, I showed a log file, right? Initially it was having a structured data, and later on the data were not a structure. Likewise it is having input text data and combined with binary inputs. In that case, it will, the Hadoop framework will use the composite input format to divide them into input splits. And DB input format, if your data set is going to be your complete database information like with the rows and columns, so likewise, then this DB input format shall be used. Okay, one more thing, if you can see it, all the input splits are with key value pairs. Okay, if whichever is divided will be of key value pairs. This input this input format classes belongs to file input format, which is with a key value pair. But when you see the database input format, it is containing only one value. Anyone can say that why it is containing only one value? Why? Because the database, no database, database when it is considering as a data set, it will not divide the data, okay, as into key value pairs. The complete data will be loaded for processing, whereas other input file formats, other data sets will be divided as a key value pair, or will be splitted as a key value pair. But when it comes to database, if your data set is of type database like rows and columns, the complete set, how many records are there, it will complete it, it take complete database values into input splits. Okay guys, that's the reason that it will have only the one type, it is not going to segregate as a key and value pairs. Okay, so till now, did you understand what is the split? And split, how it is happening, it is based on the input format types, and if which one will do likewise. And there are also some more, like XML input format types. Okay, you can see in that book, if the file is of type, if your data set is of type like with XML tags and all, then you can use this input format to divide the data, sorry, to segregate the data as a key value pairs. Okay, if it is of this type, you see our configuration files are XML files, right? If you have a large data set with XML tags and with the properties and values in that, then how it is split for processing is based using the XML input format. Okay. Okay, shall I move on? Okay, about the input file, input format, it is the first component in the map reduce. Checks the input specification of the job. Okay, splits the input file into input splits and assign to the individual mapper. So how many input splits it is happening? So based on that, the you will have your map task. Okay, till now we have seen only one input splits every time, so there is will be only one map task started. Otherwise, if it is multiple input splits, then that many map task will start. Say for example, in your line itself, if the first line is your first input split, then it will go and the processing will be done in first map task, and the second one in the second line likewise it will do. Initially the data for the map reduce task is stored in the input files. Okay, that's what I told. The files or the other objects that should be used for input is selected by the input format. Whichever your file is going to be, you are going to do the processing on, that will be based on the input format only. It divides the data splits. Okay, it defines the data splits, which defines both the size of the individual map task and the potential execution server. So based on the splits, your data set, okay, or the map task size, how much data the map task is going to process. Map task is nothing but our code, whatever we write in our map method, no, that is the map task. Okay, that is the map task, and it's a potential execution server. It is all defined by the format only. It is also defines the record reader, which is responsible for reading actual data from the input files. So record reader, what it will do, after that, when you see that diagram, once the input split has happened, the record reader only will actually give the input key value pairs. Okay, it reads the data of these splits and then it will generate the key value pair. Okay, so if you go here, mm, that is what they are saying. It actually will be reading the actual records, which is nothing but the data in the input splits. Okay, then it will do the, it will generate the key value pairs from your data. Okay, that's what it will do. Then furthermore, types of input formats, as I told, file input format is the basic class for all the input format types. And text input format, it's the default input format for the map reduce. Okay, it treats each line of the input line as a separate record, that I told, no, each line with an offset. It will offset, you understand, no, that is the start of the line. Okay, then key value text input format. It is similar to text input format. Each line as a separate record. It will treat each line as a separate record. It breaks the line itself into key and value by a tab character. What it will do, the line, complete line itself, it will break and convert into a key value pair. That's I'm not very sure. I will check this and I'll tell you. Okay, how it is dividing that into a tab and a key value pair, and that they're saying like the complete line itself, it will divide it. Okay, divide the line, and then one part it will take it as a key, and the another part it will take it as a value. That's what they are saying it. Okay, and here in the divided part that it will consider that as a tab character. Tab means a spacer character. That's what they are saying here, but I will check this. Okay, okay, I'm not very sure about this. And sequence file is the flat file structure which consists of serialized or binary key value pairs. Okay, this is the same format in which the data is stored internally during the processing of a map task. This can be used to chain map tasks, map reduce task. So sequence of files, as I told, it is a sequence of files. It will not be having any break or all. So that will be stored as such in your uh, uh, as such, so that it can do the processing on the sequence of file. Okay, sequence file, if it is of a text input format, then it will convert the key and the values to text objects. Okay, and we will use the toString method to uh, convert the key and the value pairs in a readable format. Okay, and the sequence of file as a binary format is which directly uses the binary key value pair that is stored in the sequence of file. If it is of a text format, then see, you know, right, objects you cannot read it properly if it is of text format. Text format means the lines only you can think, which every line will be considered as an object, but in order to read the object you cannot read the object in the format of directly you cannot specify it, right? Because in the sequence file text input format, the line itself will be considered as object. That's the reason you will use the toString method to convert it. Okay, but whereas in the case of a binary input format, the files are divided as a binary key and value pair. That's what they are saying. So the sequence file, it itself can have a text input file format, whereas the text considered as a text objects. So in order to read through or view the text content, you will use a toString method. Whereas in the binary input format type, your files, the values, that is the key value pair, will be of binary type. Binary type means zeros and ones. However it is stored in your data set, that way it will be visible. Okay, is this okay till now? So this is the inline input format. In the inline input format, you can specify as told the keys will be of the byte offset, and the values will be the content of the line itself. And you can specify how many lines you can give it. Maybe I will. I told you last class itself. I will find out how do we give in your code which input format we have to use it. If you don't give it also, framework itself will understand that what type it has to, how to split the data. I told right in that other diagram, these things are taken care by the framework itself, this whole part. Only if it comes to our function, we will specify how you have to do the processing. Otherwise it is taken care by the framework. Even then you can specify some of the information, like how you wanted the split to happen, how many data the split should, how many number of lines the split should have. All this also it is possible to specify. Okay, I'll maybe try to bring a program in that and I'll show you. Okay, and the db input format, it is the db input format is the input type that dates a date that reads data from the relational database. Okay, till now we were talking about a whole data set in a file or a csv file or a binary format file or a serialized file. But if you are it is also possible that you can take the relational database data itself as a input, which will be considered in the format of db input format. Okay, and it is best for loading relatively small data sets. Why they are saying relatively small data sets is, I mean, what do they mean by this line is, they say like, rather, if the database is so huge, right, we have to load the complete data. That's what I said. This a db input format will be of taking only of type 1. Okay, it means the complete database itself will be loaded, will be considered as a one split. Okay, one input split, and the processing will happen on the database, completed rows and column, one database. So if it is so huge, if the database is so huge, then it will take a lot of time, right? Because it will not do multiple splits. Why the essence of Hadoop is it does multiple splits of your data and start the processing parallelly, right? But in this case of a DB input type database, where it will load the complete data, it cannot do parallel processing, no. That's the reason, like if it is of small data sets, then if you want to analyze them, small data sets here means small databases, and if you want to analyze them, then you can use this Hadoop framework. Okay, otherwise there are other ways like HBase. Okay, this is also a database where you can HBase and using the using that you can load your relational database. Okay, and start the MapReduce. Okay, rather than using DB input formats in your MapReduce job, rather than using MapReduce engine, you can use other applications to do the processing of databases also. Okay, that's why HBase will come into picture. Okay, I hope so. This is what the file will go to the input format type will be understandable what by the framework, what type of input format type is applicable to the file, and that will be split into different splits. These are called input splits. In from the input splits, it goes to the record reader. Okay, that is other again another service, and that will generate the key value pairs of the splits. This is going to be your input to your map method which we write the programmer. Okay, and the tasks will be started on the map. Okay, that will give an intermediate result, which is again a key value pair that goes to your reduce method. In between reduce, there is a partitional which determines how many reducer will shall be useful, and they it will also do shuffling and sorting. And if needed, you can also have a combiner to give an optimized results. By reducing the load of the reducer by the combiner itself, it can do some processing, reducing activity, and then it goes to the reducer and it gives the aggregated result, which again stored into your HDFS. Again stored into your HDFS, then you need an output format type, right? That will be taken care by the framework, like whether it has to be stored as a text data or XML data or database information. Okay, so this is how the flow in MapReduce will work. Okay, so input split represents the data which is processed by the individual mapper, as I told. As a user, we don't need to deal with the input split directly. We can also control how the file is broken into splits by writing a custom input format. Okay, this is also possible. This is what I told. Like you can specify how you wanted the split. In our small data sets, the input splits we saw, no number of splits are always one. Right, maybe you can specify the input splits also, how many using some set split is there. Okay, using that you can specify that also. Custom input split by the programmer itself, it is possible. So file input format by default breaks a file into 128 megabytes chunks, same as the blocks of the HDFS. Okay, in this is understandable, no, like whatever the chunks which we are dividing, it is sometimes, like say I have 5 lines. This lines is containing like 10 characters, and this line is containing 20, 15 characters, 20 likewise. If as we have seen, if we are trying to divide based on the input split, if it is input format, if it is dividing with the offset 0 and 1 line, what they are saying is it will not be the one line all the time, it will divide the data of 128 megabytes. Okay, sometimes it will go to other next line also and take till that line. Okay, till this whole thing and store it as 128 megabytes. That's what they are saying. It doesn't always mean by a single line division, but it will divide as a megabytes. However, it is fitting 128 megabytes. That much amount of a data, that much amount of line or the lines will be stored as a one input split. Okay, is this clear, guys? How it is dividing? Okay, see, normally we told the data is divided into your HDFS in 128 megabytes, right? It means a file which I'm trying to store, it it is divided into blocks of 128 by 128 megabytes and stored here. And this block data, right, when it is taken to our map reduce engine, okay, this will be of, if it is of 128 megabytes, it will directly create an input split and it will start as your job, right? Otherwise, what it will do, it will divide it into a 128 megabytes data, and then it will start a map reducer job for each 128 bytes, and then it will megabytes, and it will do the processing. Is this clear? Can you tell me? Okay. So input split does not contain actual data but a reference to the data. That's what I told. Like it is like till where you are considering it as a divided data, it will refer. It will not be stored as a divided data. Okay. Like the first line is the input split. This will be stored separately. The second line will be like 37 into another input split. That will be stored separately. No, it is an intermediate result. It is like a reference. As I told in MySQL view, right? View will only have a reference, it will not store actual data. Likewise, input splits will be referred only. Okay, then once the processing are all done, it is a combined data only. It will not be physically dividing the information into splits and store anywhere. Okay, and the record reader in Hadoop takes the byte oriented view of the input provided by the input split and provide presents the record oriented view of to the mapper. Okay, so simply in terms, record reader, what it will do, it will generate the key value pairs of the for the mapper. Then input format class calls the get splits function and computes the splits for each file and then sends them to the job tracker. So this is what the function I was saying. It will find how many splits have happened and each split will be sent to the job tracker. Okay, this is another process. Mm, uh, process for starting your job. Okay, the maximum size allowed for a single record to be processed, there is a maximum size allowed. That is what that 128 megabyte size is there, no, that is allowed for every record. Okay, and there are some settings that you can set it in your map sites.xml, which controls how much the record reader maximum length should be. Okay, you can set this property, which is map.line recorder.max length. Okay, this you can set it to specify how much a how much a map task can process it. Okay, length of the data. Map task passes the split to recreate record reader method to on input format in task tasker to obtain the record reader for that split. Okay, so the split has happened. This is these are the splits, and these splits are going to the job tracker, from which will be creating a task for each, okay, jobs, and this task will send the data. That's what the flow is. This task will send the data to the record reader for creating the key value pairs. That's what they are saying here. So record reader is generally, so internally it does all these things, but generally it just will do the key value pair segregation. Key value pair generation is done by for each map tasks. Okay, so the create record reader will generate the method which is present in your input format file. Will do that. But if you are going in detail, like you have to modify the how your splits has to be changed and all, then you can write your custom splits itself and tell. like how much length it has to be there, and how much data it has to take it, everything you can specify it. Okay. Then furthermore, about the combiner and scheduler, is also a mini schedule reducer combiner that summarizes the mapper output record with the same key before passing it to the reducer. This is what I told. That day we have seen the temperature data where uh, if it is giving the output from two map tasks, a set of data list 1 comma 1 comma 1 likewise. So here itself the maximum temperature we found it. Right, here itself in one map task value itself, you get a maximum temperature, and in the another map task value also you can get the maximum temperature, and and the aggregation will be done between these two. So like an optimizer, you can use it. It is a default. It is a optional case, optional service. Okay, optional process that you can have it in your map reduce tasks. Large amounts of intermediate data is passed on the reducer for further processing, causing enormous network congestion. So in order to reduce this network congestion, you understand, no? See, if you are sending so many, it just nowadays we are seeing sample of data only. So if you wanted to work on with if it is a huge data, then so many map tags would have created, and all this together, if you are aggregating, if you wanted to loop through the list, then it will be difficult, right? That is the reason that you can have go for combiner. In that case, combiner plays a key role in reducing the network congestion. Okay, the process by which the intermediate output from mappers is transformed to the reducer is called shuffling. Okay, this intermediate output, that from different data nodes you get the output, right? Because data are distributed, so you get it from different data nodes. Say here 1991 result will be here, 1991 result will be here also, in different data node. I'm saying, if you think of this as data node, 1991 result can also be in third data node. Okay, we'll leave this. So we have to shuffle, right? Shuffle and sort from all the three data nodes. You have to take the data and you have to put it into the list. So this is also happening in between before going to the reducer. The keys generated by the mapper are automatically sorted by map frameworks. Okay, the keys and the values will be sorted automatically by the map framework. Shuffling and sorting in Hadoop MapReduce is not performed at all if you have zero reducers. So zero reduces means it is possible in some cases, like you don't want to find the maximum value, you want to only list, in our case, okay, only list the temperatures registered in 1991. In that case, you don't have to do any aggregate function, right? You don't have to do any sum, you don't have to find any average. That time you don't have to write a reduce method at all. In that case, this phase will not happen at all. Like scheduling and sorting of a map reduce, it will not happen at all. Okay. And about the output format, it checks the output specification of the job. Okay, record writer, there comes a record writer which writes a key value pair from the reducer phase to the output files. The output file which we specify, no, in our path, the argument 2, args of 2, this is the output file that we will um, specify. Okay, that mean to which, where you have to write the data, that will be given by the record writer. Okay, see the context we write, no, the context dot write, this will be the method from the record writer, okay, which will write into your hdfs. Here we will write our key value. MapReduce job checks that the output directory does not already exist. Okay, this I will discuss again. Output format provides the record writer implementation to be used to write the output files of the job. Provides the record reader implementation to use to write the output of the same thing. It is repeated, it will write into your hdfs. All the output files will be write into hdfs. It contains two files, which is nothing but the success file and the part file. Okay, part file will be divided based on the number of reducers. If you are having only one reducer, there will be one part file, otherwise many part files. It actually contains the aggregated data. various types of Hadoop output format similar to input format. These output files can be used as inputs while chaining of the map reduce. What does it mean is, see, you can write your map reduce task multiple ways. Okay, you can have a one map task method and multiple reducers I told, right? It is also possible you can have multiple reducer method. Okay, so chaining of map tasks, what they're saying, the result which we are getting no from a reducer, that you can again pass it to another map method. Okay, and then you can get the aggregated results. Likewise, that's what the chaining of the output files can be an input to other map task also. That's what they are saying, chaining of a map reduce tasks again. Okay, can also be the input to the chaining of other map reduce task. Till now, is it fine? How it is all happening? Input split happens at the framework level. You can also do the input split by writing your own code, customizing the input format. Input format means the data stored in your HDFS will be divided into splits based on its type. You don't have to specify it, but if you want to specify, say for example, a text file, you wanted to consider it as a just a moment. Okay, sorry about that. Okay, say for example, if you wanted to specify your own type of a split, like the text data, you wanted to do a sequence uh, input splits, how much data has to be present in the split, how many splits you wanted of that data, everything you can customize it. Okay, that is the next level of coding, maybe where you can go to your input format itself. Then once it is done, uh, then it will be like as we all know that it will go to a map task and it gives the output. That output can also be used further for further map reduce functioning. Okay guys, till now is it fine? Okay, what we will do is, I will show another program about a call reading program, call record reading. Okay, it is a data set, a small data set where the call has gone from one number to another number. Okay, what type of a call it is, and how much time it lasted. Like that data set I have. I write the program. We were writing the program in a single Java file. Right now we will split it because mapper is, we are writing a mapper class also, which is a static class mapper. We are writing a reducer class also, right, which is a static class reducer. So all these things we will split it into a file. And in our yes, Maria, I have a question whether the same task we are doing with uh, big data analysis or like a machine learning. See, big data analysis, machine learning, you will train the machines, right? Here, you don't train the machine. See, I'll tell you, this can be an input to your machine learning also. Okay, that will be advanced where you apply the algorithms. Uh, see, to apply an algorithm, you need an output, right? In the machine learning, right? Then only you can predict a graph and all those things, all those things. So the input can, you can take it from the map reduce. Okay, map reduce is going to give you an input. Say for example, the temperatures, maximum temperature registered in each year, you can find out, do an analysis and find out in your map reduce task in your Hadoop big data that maximum temperature registered in each year. Then you can take this as an input and train your machine saying like this is the history you are getting. how the temperature is registered every year. Okay, maximum temperature registered every year. Then it can predict. You can write your algorithm to make it predict like how it can be in the future years. Okay, this is kind of a one analogy you can think of. And some other algorithms like you can that also can be done separately. Okay, say in your python or machine learning, there also you do the analysis, data analysis, where you will not be involving the Hadoop HDFS storage. Okay, storage is done locally, not in your framework, in your big data. Right, in your Hadoop, you will not store the data, and also there, yeah, and also there you will work on small set of data. So if you are going to store it in your machine, or if you are going to store it in a single server, then it is like a small data set only you can store it. But when it comes to HDFS or Hadoop, there you store the data in a large scale. Okay, that large scale data also you can take it as your input. See, there is a Spark, right? Spark will do the machine learning also. Okay, MLL Spark is there. Okay, it will do machine learning also. It means Spark can work independently of Hadoop. It doesn't need an Hadoop framework also. But normally in industries, how they do is the storage unit they will take it from Hadoop, because it is very good in Hadoop. You can do it. You can easily add so many nodes, data nodes to store your data. Okay, all the activities of a replication and failure, everything is handled very well in Hadoop. So what they will do, the storage unit as a Hadoop, and they will run Apache Spark. Okay, on the data set here. So that Apache Spark MLL programming, which will do the machine learning program and give you an output. Okay, this is what it is. See, if it is coming to Apache MLL learning, obviously you have to know the algorithms and the working of machine learning, right? In order to apply it, because going to be the same concept, but how you are going to run it in Apache Spark is different. So that is how you can think of, right? So it is all about your decisions, how you are going to take. Say for example, like if you are taking the movies, movies so which are yeah relate what I can say, the number of times the ratings for the movie, if you take it, uh, if the ratings is higher, that movie will be listed on your uh, in your Netflix or in your Amazon Prime on the top. Okay, and the recommended movies, then that comes the I mean implementation of a recommended systems. You can implement everything together here, like you can have an Adobe system, then you can do the processing of this map reduce processing about the ratings for the movie. From that output you can generate a recommendation system, right? So all it is involving recommendation system, or you can list the top movies in the top. Likewise you can do. So have you all people started working on the projects? Who has started working? Because you should start it parallelly. Please send your synopsis. You have to start. Okay, find maybe we will put the top find it. I mean it was discussed in the class, right? Vignesh sir has discussed. He did he say like on the members and others, how many members? Yeah, three, maximum three or one. Okay, as can do the project together. Bring up with a topic at least. Did he give any timeline? No. 2 weeks. Okay. Topic synopsis. That is the first, like a first introduction, like what your project you want to do. That you can bring up, because in December you will have examination. Okay. By the time Hadoop will be finished, it is better that you start your project work. Getting confused to select the project. Okay. Okay, find your members. Okay, discuss with them. Or if you are doing individually, if you could not get the topics, let us know. Okay, we have a set of topics, and from our old project topics also, we'll share the topics. You can pick it from there, or else you can take that as an idea and search through which you can do it. Okay, do a nice project which will be very well used when you are going for the further in your career. If you are going to choose data science projects, they will ask any interview, only projects they will ask. Or if you had worked in a company about that project only, they will ask. Okay, if you do a good project, malaria detection, face attendance, yeah, any, yes, you can do that. Yeah, malaria detection is good. Face attendance, and try to come up with a very good data set. Okay, not a very small whatever we are discussing, no? Because more than records of 1,000, 1,000 is very less. If you get a large data set, it is a very good. Okay, try to collect that way and work on it. Yes, Malan, you can do that. Face attendance, I don't know, face attendance, face deduction, you are saying. Okay, I think that may be discussed in ML. You try to extend it. Okay, in your ML class it was discussed, no? You try to extend that. Okay. Okay, now we will see one program in that the other one, okay, where we will see our data set. I will open it. Just a moment, I'll take the data set. Thank you. Okay, I have created a new CDR project. Okay, then I will import the jars for that. Hadoop jars we need it. It is not import, it is build path. In the build path, I will set the libraries. Okay, in build path, configure build path. In that, we will add the external jars. In the class path, we will add the external jars. Actually, it is showing the build library as 11. That I will change in the compiler. Okay, compiler. In the compiler, I will change that. I will uncheck this, change that to 8. Okay, we will run in 8 itself. Apply and close. Yes. Sorry. Then I have to again import the libraries. In the build path, configure build path, I will add the libraries. So the libraries are in other locations. Computer, mm, it is in USR, in our, where our Hadoop is present. USR, local Hadoop. In that share folder is there. In that Hadoop. Okay, we will import all the libraries. Client libraries, open, add external jar. Then in the Hadoop common libraries, I will choose. Folders, don't choose it. Open this library also, this common library also, we have to set. Open, add external jar. Then again go to Hadoop. Then we will choose HDFS library, HDFS jar files. Control A, open, add external jars, map reduce, open, add external jars. Then tools, it will not have anything. In the yarn, we will choose the yarn jars. Okay, folders, don't choose it. Open. All the jars are applied. Apply and close. Okay, so I will have the files here, class files. One is like a CDR main class file we will have. Okay, CDR main. It will have main method. Then we will have a mapper class, a reducer class. Okay, CDR mapper. Three classes I'm going to write. Okay, here is the program src new Java new class. One other class I will have CDR reducer. Okay, main I put, it should not have main. And another one is a parser file where we will read our data set. Okay, CDR parser. Okay, we'll start from the main method. In the main method, we will write what are to be required. Okay, for that we need all these paths, right? I mean, we need to import the class paths. So I will copy it from the another file. Okay, I am not writing it. The map reduce, we have word count, right? From there I will copy it. This import files, I'll copy it and put it in the CDR main.java file. Okay, these are the configuration files, everything we needed. So I have put it. So what I will do here, I will going to start a job. Okay, we can try this writing it in a try catch block also, because if you remember in your word count, we have thrown the in the main method, we have thrown the exception, throws exception we told, right? It means whoever is calling this method will have all this exception added. We can also write it in a try catch block, rather throwing it in a try catch, we will have this. Okay, so job reference, for the reference job reference we have to give. So job dot get instance. Okay, and we have to set our class files. Okay, job dot all the class files, right? Set the common class file, set jar by class, which is nothing but your CDR main is going to be your class name, right? That we will see set here. Then afterwards we will set all the mapper reducer all the class names. Okay, this is done. Then job dot set mapper class. Okay, we will set it null. Later on, we will set the proper class name, file name, job dot reducer, job dot set reducer. Okay, set reducer class. Then later on, we have to set the output key method. Okay, job dot set output key class, which is going to be whatever we are going to store, it will be of text type. I will tell you. Okay, then job dot, then we will set the output value. Okay, what output value it will, how the output value will be set output format class. Oh, value, it is value class. It is going to be the int writable. Okay, this aggregated result we are going to write dot class. Then afterwards, this you will do it all the time. Okay, these things you will do. First you have to set the job to get, we will get the instance of the job, and you will set all the classes. Then afterwards you will do the completion. How it is done, system dot exit. Okay, exit the job dot wait for completion will be if it is for true or false. Based on true or false, you will return 0 or 1. If it is true, you will return 0, otherwise you will return 1. Okay, we can also set the name for the job as job dot set name. Okay, name like call processing program, anything processing program, likewise. Okay, we have set whatever is needed here, and now we will go to our mapper class. So this is understandable, no? So here we don't have to give the input format. Okay, input format we have to set, that I have not given, because in the argument while you are writing map reduce, when you are starting the map reduce job, how do you start it? This is how you will start it. Okay, Hadoop jar file name, and a class file name, and input path. This is argument of 0, args of 0, and args of 1. Okay, that is what, that this also we have to mention it in our main. Okay, which is argument of 0, which is argument of 1, that I will give it like a job dot, not job, this is file input format, file input format. See, this file input format only will specify. In the file input format, we are going to give argument of a 0, right? Argument of a 0 is going to be your file. Okay, whichever your data set file you will specify. So this file input format will do all the splitting and all by itself. Okay, but add input path, which is nothing but the job. It takes the job under the path. The path is, you will have a new reference for the path, new object for the path, which is nothing but args of 0, and likewise add output path equal to job reference of 1. This part is clear, no? So this input output path only, set output path, this is not add, this is set output path. I'll tell you why set output path, it is throwing error. It should not be an error. Set output path. Okay, some mistake is there. Okay, I'll check this one. No problem. So what all we are doing it, this you understand, no? What we are doing. So this is the input formats which we have seen. Okay, if you are adding this path, which is nothing but you will say give your dataset name here. It will divide the input splits on all. In your main program itself, you can split. you can give the set split method. Using that you can specify the splits or not, but now we are not doing that one. We're just concentrating on how you process your data set. Okay, and the set output path, it will tell like where you want your output to be present, which is going to be the second argument. Okay, this is how we give, right, in the set output path. Yes, set output path likewise only we give, but it is throwing error. We'll see that. Okay, CDR main. Okay, this is not input format, it is output format because it is output file, no? Till the main program is fine. Shall I move on to write the mapper task? Okay, then what we will do, we will pass the data in the parse in the sense, read the data in the data set. See the data set, we don't know which field is what, right? What we will give the name for the, by seeing this data we can understand. If you see that vaccination data in the header, it was having all the headings, like it is which are the countries total vaccinated, like what are the vaccines given, likewise it is there. But here it is not given. So what we will do, we will give for each field, we'll divide the field and we will give some name to the field, so that it is easy for us to go through that. So for that I am going to have a CDR parser. The parser will pass the record and it will give the name to that. So what I'm going to do in this is, we will have the following, uh, this one, what is that, fields. Okay, fields is nothing but variables. String ID variable we can have, and we can have the calling number. Okay, first the second field you can consider as a calling number, called number, start time, when the call has started, end time, and a call type. Okay, and the call cost, how much cost it took for, and the status. Okay, so if you see that file, this is the file. First one, we are giving it as an ID, calling ID, the caller number and the called number, okay, whom the call has gone, start of the time call had happened, end of the time call had happened. Okay, and the call type. Okay, and this is the cost for that call, and the status of the call. So for all these things I'm going to store it. These are the variable names which I'm giving it. Okay, so how many fields? One, 2, 3, 4, 5, 6, 7, 8 fields are there. This one, 2, 3, 4, 5, 6, 7, 8 fields are there. I have given each name, each for each field I have given a name. Okay, these fields are separated by the comma, right? So that you can use a tokenizer to separate it. Okay, what I will do, I will have a constructor here. Okay, I'll give a constructor like CDR parser. In that text value, it is going to be the input. I will tell you how it is working. In the constructor, what I will do, I will do some initialization. Okay, string record equal to value dot to string, then string tokenizer, tokens we can give equal to new string of record, comma. Okay, I'll explain you. So string tokenizer, the input to the text CDR parser is going to be your each line. Okay, the complete line. Okay, that is going to be input to the constructor. That constructor, it is a text object, right? That I'm converting it to a string. Okay, because object we cannot read it, string I converted. I'm using a string tokenizer class to separate each of the value, okay, into a record. Okay, that it will get stored each value, each sorry value, the record will be divided based on each delimiter comma, and it will stored in the tokens we can give it. Okay, so what I will do, each token I will store it in a value. This is throwing error because I have to import what it has done. Import string tokenizer, import yeah, java dot util dot, it is belonging to util class, util dot a string tokenizer. Okay, then afterwards I have to import the text also, which is belonging to Hadoop libraries, right? So import org dot apache dot hadoop dot io dot text. Okay, this class is also imported. So now tokens are divided, so each token, so id, I will store the first token likewise. So how do we store the tokens? Tokens dot next token is there. Okay, using this method, it will take the first token here and store it. Okay, next token will give the next token. See, if this is the input, if I take first line as the input, okay, text value equal to, this is the input. Control is it. Okay, I'm copying it from somewhere else. 1 minute. Okay, this is the input. Okay, if this is the input, then this will divide. Okay, first one is the token, so that it will store it here. This one is the token that will store it in the id, and the next is caller, calling number equal to tokens dot next token. Okay, likewise you can store every tokenized data. Next token. Okay, likewise for all the fields you can store it. This is called a number. This is start time. This is end time. This is call type, call cost. Okay, call cost we will store it in a float value. So what we will do, I'll tell you what I'm doing. Okay, parse float tokens dot next token, then status equal to tokens dot next token. Okay, what how do I get all this? This is throwing error. Okay, call cost is a floating point number, so I have to give it as float. Okay, now it is all fine. This is a comment. Okay, okay, likewise I'm doing it. We also going to get the data from here. Okay, I'll finish this program and I will explain it. Okay, what I'm doing it. So public string data which I'm going to get is a get ID. Uh, 1 minute. Okay, this get ID also I will do it later on. No problem. Let it be there. I will do it later on. Okay, so in this program, what I'm doing, I've given all the variable names, and I'm going to take the tokens and store it in each of the tokens. That's what I'm doing. Next token, next token. And for the call cost, it is a floating point number. We wanted to take it as a floating point number. How we are taking the input? Input is of text, right? Text object. Okay, text object is of type Hadoop class. It belongs to the Hadoop libraries, but that we wanted to store it into a string, right? That's why we are converted into a to string method. Using a to string method, we stored into a string. But call cost, we say that it is a floating point number. That's the reason we convert that into a floating point number. Float dot parse float. Parse int, if you remember, we have done with the vaccine data, right? The other day. Here we did a parse int, right? String value we converted into a parse string. So likewise, float value we are converting it into a floating point number. So now it will have all the data into this one. So what we will do in the mapper task, we will write the program in the mapper. Till now it is fine. We have written a main program where we have initialized all the classes, and we are writing a parser in order to give the names for the fields and store it each each value, each tokenized value into the fields. Okay, okay, till now it is fine. These two programs, Java programs. Then now we will write our mapper and write our reducer to do the actual tasks. In the mapper, what code we are going to write is, we are going to find out the call cost. Okay, for each of the call, the how many the call cost has, how much time the 1 minute, I forgot the problem statement. Calling number, get the call cost for the, okay, for how the each of the number, each number which how much call cost it has done, how much time it has gone for the call. So what is the cost for the call, that we are going to see it. Okay, so problem statement will be, the question I can say like, find the calling cost for a particular number. Okay, how much calling he she has done. Okay, that we are going to find out. Okay, so for that we have to write our program. Then again we need to import all our packages. We will have all, only these packages are enough. Packages are like import org dot apache dot hadoop dot io dot a long writable. We can have it as a int writable, and the same thing you can have long writable. Long writable is for the numbers, right? Or for the output value, I think we will see. No, it is an input key. Input key is nothing but long writable. Why? Because the id is a long, this id we are taking it into a long value. Okay, that's the reason we will give it as a input value as a long writable. Then import others also. I will show tell you why we have imported all this. Hadoop hadoop.io.text dot apache dot hadoop dot map reduce dot mapper. Okay, in this this is the mapper class, right? This actually extends mapper. So in that we will mention the long writable, the key value pairs. Okay, what is going to be the input and what is going to be your output type, that we will mention. writable, and the method we have to give, the method is type public or protected type, it is protected void map. In this a long writable key and a text value. Context is context. Okay, and it will throw it throws an exception, so that also we will mention. Throws IO exception and interrupted exception. So this I have to import it. Import java.io.io exception. Okay. So in the map method we will write, I explain it again. Okay, don't worry. So I am going to use the CDR parser class, create an object of that, new CDR parser, and that I'm going to have a calling number equal to parser dot get calling number, and the float cost equal to I will tell you what I'm doing. Okay, cost. Okay, so from I'm creating what I'm doing in a mapper classes. Mapper class, this is the definition, because whichever mapper class you are writing, it is going to extend from the Hadoop mapper class. Hadoop mapper class is having an input. This is the input, and it will generate the output as a text and int writable. Okay, so input is going to be coming from our input splits, right? Whichever is divided. So the first I'm taking it as a long writable type, and the value of that I'm going to give it as a text, and we are going to generate the map from the mapper, the text and the int writable. That is whatever the problem statement I told, like particular number, phone number, how much call, how much call for how much cost he has made the calls. Okay, so that we are going to find out. For that we need a calling number and the call cost for that. Okay, so where we are going to get that result, in our parser we have written, right? We have we divided the complete first line, that is the record, and we have tokenized it and stored it in calling number, call cost or call type. Okay, from this it is stored. So what I will do here itself, in the public string get id, it will return the id is nothing but your first id. This is the id. I also have to return the calling number, called number and all. So what I will do, whoever is calling this get id will get the id, right? Now we are going to call get calling number. Okay, get calling number, this will return calling number. Okay, you understand, right? Calling number, we are getting it in this program, the CDI parser program. That whoever is calling, how we are going to return it, we are going to return the calling number. So this class, no mapper class, what it is doing, it is calling the get calling number. We have created an object for the parser. In the parser, there is a get calling method that we are calling it and storing it in the calling number. Likewise, we also need the cost. So for that, we will also have another method. Okay, where is the parser? To return the get calling cost. Okay, cost is of type of float. Okay, so we will return the get calling cost, get call cost, like that. Then we will return the call cost. Okay, where we are going to return into your mapper, you are going to return the call cost in the cost. So for see this if it is taking, if we are taking the number 8131166797, this had made many calls, right? The what are the cost for each of the calls, that it will aggregate and it will give the result. That is our idea. We wanted to find the call cost for each phone number which made the call. Okay, so it will see so many times it made the call, and the call cost also is registered, that it will aggregate it and it will give the result. So for that reason we need the calling number and the call cost. Okay, so here we have to mm, aggregate the result. So I will do this one, key value pairs we have to combine it. So I will do key out equal to new text. If you keep practicing, this program will be easy. Okay, I have already done this. I'm just writing it to explain. Okay, this one, and interwritable value out. Value out means output value from the mapper I'm writing. New interwritable one of one. Okay, then context dot write, in that key out and value out we are going to store. So what this is, we have to inform about the output, right? This is the input, this is the input from the splits, and this is the output, right? Output, I told the key is of text format, and value is of int writable format. So what this will do, the output will be like this: whatever the number. Okay, control is that the number is like 81311311 and 66979, 66 and 979, comma, how many times it has occurred. Okay, and likewise, this how many times means it will keep appending. If it is appearing for 10 times, then it will keep appending 10 times, and in the reducer function we will sum it up and give the results, how many times the call has made. Okay, this is the calling number. The calling number has made the call how many times. Okay, that's what we are aggregating it here. Is this okay, this map program? Okay, actually this program will not find the call cost. What this program will do is will find the number of times the call has made by a particular number. This is wrong statement. So the number of times a call has happened from a particular number. That is what we are going to aggregate it. Okay, this is the mapper function. Fine, I will write the reducer and show. It will be keep appending with 111. Likewise, then it will aggregate number of times the call has happened in that by a particular number. Is it confusing? Tell me. What all we have done, we have defined the main. Okay, we are reading in the parser file the lines, each input line, and we are storing it in a mapper. We are going to see how many calls the particular number is made, or else you can also put this the cost of the call here. Okay, here I have given one, right? Instead of one, the value out, you can give it as a cost itself. Okay, that also is possible. Here I can give the value as cost. Okay, that is also possible, but it is of type float. Control is that. Okay, that but that you have to convert into an integer and store it. Then in the reducer function, what you have to do, you have to do an aggregation. That also I will write. So reducer, how you will write it as a main method. I will remove this. So reducer will extend from the class a reduce class, reducer class, which will take the input a text input from the mapper text int writable, and the output it will generate as a text int writable only. Text is the key, int writable is the value. Okay. Yes. And it is throwing error because I have to import the classes. Input output. It needs classes like import org.apache.hadoop.io.int writable. Similarly, import text class it needed. Text and the reducer class. Okay, control C. Hadoop.map reduce dot reducer. Okay, so this is all fine. Now we will write our map reduce method private protected. The signature for this is like this. We are just overriding the method. Okay, that's why we have to use the same signature. Void reduce text key comma I treble int writable values comma context. Then it will throw that exceptions. Okay, so in that we will do all these things. Int sum equal to 0, that aggregation. Then the same thing for int writable x values sum plus equal to sum dot get, not sum dot x dot get. I'll tell you, explain you this one. Okay, once it is done, then we will write into our HDFS key comma new int writable. Okay, so what I'm doing it here, so whatever they're going to be the output from the mapper.java, okay, the number of calls made by a particular number, okay, the number of times a call has happened from a particular number, that input I'm passing it to the reducer. Reducer is taking the input from the mapper and it was going to generate an input of type key as text and value as int writable. The reducer method is taking two inputs and the context, okay, where it will write your data into HDFS. So it will have a list, right? So it will have the list like this, as I told. Here is this way, control C and reducer, comma 1 likewise. Right, it will have a complete the number of calls made like 1 1 1, likewise it will keep going on. So from this list it will aggregate it. So the values is the values in the list, that it will keep summing it up. Okay, x dot get, it will take the value and sum it with the sum, and that we are going to write it in the value. Okay, so this problem statement is this way. Otherwise, if you wanted to find the calling cost for the call, then your input or the called type, okay, then your value value out will be that cost. That also I will change it. So first we will run this program. Okay, in the main, did I finish it? In the main, we have not mentioned about the mapper class. The mapper class is a CDR. When I compile it, it will give mapper dot class, and this also will give a CDR reducer dot class. Okay, that I have written. It will throw error because I have written try, but I have not given the catch block. That's why we can give a generic exception e. Okay, e dot print stack trace. Okay, so reducer class is wrong. It is throwing error. Okay, is this all fine, guys? So what I have all done here is we have written mapper reducer in the mapper. This is understandable, right? This is going to be your input split key value. Record reader gives an input split, no, in the map that it is going to be. Okay, it will be written temporarily in the context. Context means HDFS itself. Then that data, the key is the calling number. Calling number, how am I getting? I'm getting it from the parser. Okay, get calling number. Then value I'm going to add this problem statement is number of times a call has happened. Value I'm going to add 1 to that. Okay, this is the mapper, and in the reducer we are going to aggregate it. So this is going to be the same method. Okay, or if you are going to find the max, then that you will do it max, you loop through it and you will find the maximum of that. Rather than doing sum, you will do a max. Okay. Okay, now I will create a jar file for this. Here itself you can create, right click, export. Okay, then it will have a jar file. Jar file you can create it, and your CDR program, right? Then you can check it. See, Java files are there. Okay, all this you choose it, class path and the project, both you will choose. Okay, then you can give your jar file name, which location you wanted to create. I've given home nightlight in my local directory documents. In demo, I will give the jar file name as different, like a cdr dot jar. Okay, then we will finish this. It will generate the jars. It is saying it is there is a error. It's okay. Yeah, not error, warnings. The file is compiled fine and the jar is generated. We go to our local directory. Okay, in this we go to documents. This is where I have my MapReduce jar. In this a demo, cd demo. Somebody is using my machine or what? Just a moment. Okay, I will see if my processor. Somebody is using my mesh. Okay, something is happening. I will open the new window control. Okay, sorry. Okay, exit this. Okay, I will do Control S, JPS. The processes are running. Then I will see where my documents are present. Cd demo ls. Okay, I have created a jar file, right? That it is here. Okay, ls hyphen. What happened? ls hyphen lrt. So cdr.jar file. Okay, that it is created. What I will do, I will start the map reduce job here itself. Wherever your jar is present, you can start it from here or give the path. Okay, my process are running, all are fine. So Hadoop, file name is jar file name is jar, cdr dot jar, and main file name is cdr main. Okay, that is my main file name, cdr main. And path, okay, I have to put the data set into our Hadoop, right? HDFS, right? I have not put the data set. If you see Hadoop, excuse me, uh, HDF Hadoop FS hyphen ls, I don't have that text file. That is the data set. The data set is this one. Okay, cdr.txt. This I will put it in my Hadoop. Okay, that it is not there. Then how does it will do the processing? It will not do processing. So Hadoop, mm, fs hyphen put, it is there in the downloads, my cdr text, that I will put it in the root directory. This is the command hadoop fs put, downloads directory, I put it in the hdfs. Okay, okay, now we will check whether it is actually present. Okay, see cdr.text has come. Okay, then what I will do, now I will start the map reduce job. uh, Hadoop jar cdr, sorry, cdr dot jar is my jar file name, and class file name is cdr main. Cdr main class file means this one. Excuse the 1 minute. This is the class file name. Okay, that's what I am giving it. Okay, cdr main, and the which is the data set I have to work on in the hdfs, cdr dot text. Okay, you have to see this one root. In the root, cdr dot text is there. Then output file I wanted to generate is cdr out. Okay, in the root directory only you can have it. Okay, enter it. Let's see, it works fine. It is throwing error. Output directory not set. File output format, check file output format 156. There is some error in my code. Set we have set the output directories also. Here it is saying it is not set, but we have set it. This is one, it is throwing error, but I have set it. I think some job configuration problem is there. 1 minute. Set output. I don't know what is this problem. It is throwing some error saying output directory not set. I think this get uh, here it is having some problem. Conf configuration file I have to set. I think just a moment. Same thing. I will change it as per our word count. So this is the problem. I think we'll set the configuration file also. Otherwise, also it should get it, but it is throwing error. Configuration file job. This I will comment it. This will be call processing. It's okay. Get instance. I'm setting the configuration file. I'll save this. I'll create the jar again. I will delete the old jar because it is not working. So I will remove this cdr.text jar. I will create again a jar because I've made a changes in the code. So cdr program, right click, export jar, Java jar. Next, cdr program chosen and browse the path in home, Nilet, in documents, demo, save. I'll put it as cdr.jar. Finish this. Okay, it is done. Now we will have our latest CDR. So with that, we will check it again. It is still giving error. Can anyone see what is the error? Input job configuration is wrong. Output directory not set. Or I am running the job wrongly. CDR main is the class name. See, you can see the stack trace when it is giving the error, how the job has started. See, from your main, it is reading. Wait for completion, submit, and all it is checking. Then, when it is trying to read the file output format, check specifications, it is throwing this error. Okay, I think I found the error. It should not be an error. Can anyone see what is the error? Job, it is. 1 second. 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 1 second Okay, then I will check this error. You people also try it. It is wrong. It is job only. Okay, I'm changing it to a different one. It is job. Okay, I will check this guy. Some error is there. I'll check it because it has to work. There is no problem in this, but still is showing. Can you people tell me, is this a problem in this statement in this Hadoop jar starting? Is there any problem in this? Invalid job configuration exception, it is saying. Okay, I'll check this. Okay, I will put this file. If you possible, you also try it. I'll check it and I'll let you know. And there is another program. It is like a digit count program. I'll not write the program tomorrow. I will show you. And in this program itself, with a little modification, you can find the like a calling cost for each of the number. Okay, since it is a float number, that we have to change. Where is it? That also I will chase show you tomorrow in the next class. Then we will start with the other applications in the mapper. Okay, to increase it got closed. That's why. Zoom out. Okay, here in the value out, you can pass it as a cost, but the cost will be of a floating number. But we say this cost is of int writable type, right? So you need to change this cost to of integer type. Okay, or if I store it as an integer, this will throw error. We have to convert it into an integer and store. Okay, then also it is throwing error saying cost to int writable. Okay, here we will pass cost. Fine. Then it is throwing error. No, this is wrong. It is integer that you can store it. This also I will show you tomorrow. Okay, if you, it is like this particular number, the total cost for the particular number, that also we can find out. Okay, this is throwing error. Some small mistake I've done. I'm not sure where it is.